Okay, here we're going to explain a little bit more about the charge of the object. First thing that we need to understand in this simulation is that every single object here is neutral. Why they are neutral? Because if we count the quantity of negative and positive charge, they have exactly the same quantity. If we see here the balloon, we have 1, 2, 3, 4 negative, and we have 1, 2, 3, and 4 positive. That means this is going to be neutral, since they have the same quantity. Now, in the wall, it's exactly the same. The wall have the same quantity of positive and negative, and then also the jacket is exactly the same. If we can see right here, they have exactly the same quantity of positive and negative. Now, see what happened. When they are neutral, because they have the same quantity of negative and positive, nothing's going to happen. When I move the balloon close to the wall, there is no type of interaction, nothing is happening. And when I move the balloon close to the jacket, it's exactly the same, nothing is happening. Yeah, no interaction. Now, see what is going to be the problem, or the problem, or what it needs to happen. When I rub the balloon over the jacket, he gained electrons. Now, these electrons are not created. We did not create electrons. See what is happening. Let me move this right here. The jacket lose 1, 2, 3, 4, 5, 6, 7 electrons, and then if we count the electron that the balloon now gain is 1, 2, 3, 4, 5, 6, 7. That means what? That the new electrons that the balloon has right now, they came from the jacket. I mean, there are no electrons, negative charge that are being created. If the negative charge from the jacket, they move from the jacket to the balloon. Now, this is the problem. Now that we have the negative charge in the balloon, see what happens when I move the balloon close to the wall. We can see that the negative charge in the wall, they are trying to move away from the balloon because they don't want to be together, since they are both negative. But when I let the balloon close to the jacket, we can see that the balloon is moving to the jacket. There is attraction. Why? Because they are different. Now the balloon is negative, but the jacket is positive, since have more positive than negative. And see the motion right here. Yeah? And when we rub the balloon in the jacket, all these negative charges, they are moving from the jacket to the balloon. They are not new. These are negative charges that the jacket had before, and now the balloon have it. And we can see that the negative charge, they don't want to be together, and that's why they repel each other. Or if the jacket is positive and the balloon is negative, we can see that they have what? Attraction. They want to be together. But the point that we need to understand is these are not new negative charges. This negative charge came from the jacket to the balloon. Okay, let's try to explain this concept a little bit more. Now, let's think that we have right here the balloon, and we have right here a box. Now, let's think that this balloon have 2 positive charge and 2 negative charge, and the box have 2 positive charge and 2 negative charge. Now, these 2 objects are neutral. Why these objects are neutral are because when we find the quantity for positive and negative, we are going to find if they are positive, negative, or neutral. See right here, this one have 2 positive charge and 2 negative charge. Now, when we add them, this is going to be equal to what? 0. And in this one, in the box, is exactly the same. We have two positive charge and two negative charge. When we add everything, is equal to what? 0. That's why these are neutral. They have positive, they have negative, but they have exactly the same quantity. And that's why they are going to be neutral, because they don't have more positive or they don't have more negative. Now, this is what happened. If we come right here and the balloon rub the box, they are in contact one with the other one, and the balloon start rubbing over the box, this is what could happen, is that one of these negative charges, it can move to the box. And now we're going to have a problem, because we have two positive charges in the balloon, and now we have three negative charges in the box. But if we have now three negative charge in the box, what will happen in the balloon is that the balloon have two positive, but now it's going to have only one negative charge. If we want to check if the balloon or the box are positive or negative, this is what we're going to do. We have two positive plus one negative. Now the charge of the balloon is going to be what? Positive 1. And in the box, we have two positive plus three negative. And when we add this right here, we have that this is what? Negative 1. And now we have a problem, because the balloon that we have right here is positive, and the box that we have right here is negative. Now, since they have different charge, the balloon is positive and the box is negative, now we're going to have an attraction. They will want to be what? Together, since they have different charge. Okay? But the point that we need to see right here, we have 2 or 3 points. First is this negative charge that we have right here was not created or destroyed. It moved from the balloon to the box. Okay? And that's why these two objects change from being neutral to now one is positive and the other one is negative. Okay. Now we're going to be working with a few questions or example about this topic to try, to review and try to understand more these problems. Now, first problem, a neutral plastic rod is rubbed with a piece of animal fur. Now we need to describe the charge on each item. Come on, what is going to happen after you rub them together? Now, let's go. With this problem, it's really good to try to draw, and then these draws are going to help you to understand and to analyze these problems. Now, let's go right here. We have the first object, that is the plastic rod, and we have the animal fur. It goes right here. Now, both of them are neutral. That means that they have charge, but they have the same quantity of positive and negative. That means, let's go right here, that this one have two positive and this one have two negative. And for the other one, let's do exactly the same. 2 and 2. Now, how we know that they're going to be neutral, since when we add them, we have 2 positive plus 2 negative. This is equal to 0. And here is the same, 2 positive and 2 negative, that are going to be equal to 0. Now, if we rub one with the other one, we need to have a motion of only, remember, the only charge that it can move from one object to the other one is going to be the negative charge. That means the negative charge in one of these objects is going to be, it will move from one to the other one. Now, let's say that this is the rod, and this is the fur. Now, if the rod will have a negative charge, and therefore we have a positive charge. This is going to be the answer. And now check why. After you rub them, if we need to have a motion of charge. That means both items are going to be neutral? No. One of them is going, both are going to be negative? This is wrong, and I'm going to explain why this is going to be wrong. The answer C is going to be right when they say the rub is going to be negative and the animal force is going to be positive. And check why this is the right answer. If the rod is negative, that means that one of these negative charge from the forward move to the rod. That means now we are going to have the rod right here is going to have 2 positive charge, but it's going to have 3 negative, and the forward is going to have 2 positive, but only what? 1 negative. Let me put the names here, then it's easier for you to understand. Now, when we check here now the numbers, we have 2 positive and 3 negative. This is equal to what? I'm sorry. This is equal to negative 1. And here we have 2 positive and 1 negative. This is equal to positive 1. That means the answer is C, since the rod now is what? Negative, but the force is now what? Positive. Something that we need to remember, when these two have different charges of the net charge, that means the add of all the charge in the object, this one is negative and this one is positive, they are going to have attraction. They want to be together since the charge is different. When objects have different charge, positive and negative, they are going to move toward each other. They want to be together. If the charge is the same, they are going to move away from each other. Now, let's go to the next problem. In the next problem, we have 2 positive charge objects move toward a negative charge object. I'm sorry, we have one that is positive and one that is negative. What is the motion of the object when they come close to each other? Now, we need to have if they're going to attract each other or repel each other. And let's go right here. We have one that is positive. Remember, if this one is positive, what that means? We have positive charge, but we have what? Negative charge. But the problem is that we need to have more positive than negative. This is the only way that the object is going to be positive. Since we have 2 positive plus 1 negative is going to be equal to what? 2 positive. Now, the other object is negative. Now, if the other object is negative, this object doesn't matter, always need to have at least 1 positive charge. That means, let's say that he has right here 1 positive and it has 2 negative. And then we have right here 1 positive plus 2, I'm sorry, let me do it again. We have 1 positive plus 2 negative. This is going to give me a charge of what? Negative 1. This is to try to analyze the problem now. Now that we have one that is positive and one that is negative, what is going to happen? First answer is neither object have any effect on each other. You guys know that this is wrong. This is wrong since one is positive and one is negative, something is going to happen. The only way that they have a non-effect, no interaction, nothing is if both have exactly the same charge, positive and positive, negative and negative, or 0 and 0. The object move away from each other. This is wrong again, because they are going to move away from each other when both have the same charge, like positive and positive or negative and negative. If they are positive and negative, they are going to move away from each other. And letter C, that is the right one, see right here. They move what? Together toward each other. Why they want to move together? Since the first charge and the second charge are what? Different. Since one object is positive and one object is negative, they want to be what? Together. And that's why the answer is going to be C. Remember, letter A is wrong because they don't going to have any interaction if both of them are neutral. If both of them, the charge is equal to 0. B, that is wrong also because they move away if they have the same charge, positive and positive or negative and negative. C is the right one since one is positive, one is negative, and when the charge is different, they're going to move close to each other, toward each other. Now, last problem here. We have a neutral glass rod. It's wrought with a piece of silk with no net charge. No net charge means that the silk have the same quantity of positive and negative, and also the glass. Let's see, we have here the glass. We have here the silk. Now, both are what? Neutral. Let me put right here. We have 2 and 2. And let's go with this one with 3 and 3. That's neutral because we have 2 and negative 2 that is equal to 0. And here we have 3 and negative 3 that is equal to 0. Now, the rod gain positive net charge and the silk gain a negative charge. That means if the rod is going to be now positive, this is what we need. This is going to be positive, the glass, yeah? And now the silk is going to be what? Negative. What's supposed to happen? And this is the problem right here. For this one to be positive, the only way is that one of these electrons move away from the object. And he will move from the glass to the silk. It's the only way that the glass is going to be positive. Now, what that means is that now we are going to have 2 positive and 1 negative. That this is equal of 2 and negative 1. That is equal to positive 1. And now, in the other one, we are going to have 3 positive, but we're going to have 1, 2, 3, 4 negative. And we have 3 and negative 4. This is going to give me what? Negative 1 when we add them now. What is the sum of the charge of the silk and the rod? And this is what we're going to do here. When we want the sum of the charge of both together, in the beginning we have 0 and 0. And 0 and 0 is going to give me 0. Okay? Now, at the end, we have positive 1 and negative 1. And when we add them, it's equal to what? 0 again. That means the answer is going to be 0. But we have a trick. If in the beginning is 0, at the end it needs to be 0. If in the beginning we have 100, at the end it's going to be 100. Why? Because we cannot create or destroy charge. The only thing is that the charge from one object moves to the other one, but the net charge, the sum of the charges in the beginning and in the end are going to be the same if we are calculating both objects together. Okay? And this is how we can do this problem.